Welcome back to Disruptors Unleashed, a series that highlights the disruptive technologies shaping our world. Previously, we explored the Building Tomorrow project, a monumental project that aims to reimagine the iconic Eiffel Tower as a sustainable tower of tomorrow through the latest digital solutions. Today, we're delving into the transformative power of modeling and simulation, otherwise known as MODSIM. We're joined by Monika Balk, High-Tech Industry Solutions Senior Manager, and Kamel Terki, High-Tech Industry Solutions Technical Senior Manager from Dassault Systèmes. They will reveal how the real-life value of MODSIM is revolutionizing the high-tech industry. By synchronizing modeling with simulation, this innovative approach brings unprecedented speed, efficiency, and collaborative performance to engineering teams and high-tech businesses like never before.
Good morning and good afternoon. Thank you for being with us today. I'm Nino Howard from the Dassault Systèmes High-Tech Industry team, and with me today are my colleagues Monika and Kamel, who are experts on the engineering of connected systems. Hello, Monika and Kamel.
Hello.
Hello.
Today, you are going to share your insight about the real-life value of MODSIM for high-tech, which is gained from real-life customers and our technology. So MODSIM is essentially a new, innovative approach to synchronize modeling with simulation. So let's hear now from you how it brings more speed, efficiency, and performance to engineering teams. Monika, let's start with the speed aspect.
Yeah, thanks, Neno. Indeed, in high-tech, speed is key to encourage and accelerate innovation. Let's imagine a device, for example, like a USB connector, which is a critical connection to transmit high-speed data, and it needs to be designed for optimal connectivity. So the first thing you could do with simulation is to make sure that your electromagnetic signal properties are optimized. So you can make sure that your transmission and reflections are optimum until very high frequencies, because due to the high data rate requirements, we need to go up to very high frequencies. But then if we think about how we use as a consumer such a device, we're actually abusing it. We're plugging it in and out multiple times. And therefore, a designer up front has to make sure that during the use of that, the displacement doesn't get too big, or stresses induced in the device will not be too large such that it breaks. Then such a connector is not living in isolation. It will be placed on a printed circuit board for further signal processing. And with simulation, you can also make sure that electronic cooling measures applied to your printed circuit board still hold even when you place the connector. Additionally, simulation helps you to avoid electromagnetic interference and therefore ensures regulatory compliance and helps to get your devices through regulations much earlier in the design cycle. In the end, simulation uncovers potential problems early in the design stage and also helps to minimize the number of physical prototypes and therefore shortens development time and cost.
That's very interesting, Monika. I imagine such simulations are not singular, but need to be done many times along the design and engineering stages.
Absolutely. From the early design until manufacturing handoff, many engineering and business functions need to collaborate efficiently. Therefore, it is important that you have a data-driven approach, meaning the simulation expert performing the structural simulation is working on the same data as the, for example, electromagnetic expert. You can make sure that nobody is working on outdated models, which is very helpful when teams don't share the same room, which is actually standard today. Then let's think about, with simulation, you have generated a lot of candidates which could be possible for your device. And then it is also helpful if you directly can connect your corporate requirements to make sure that you only look for the candidates which actually fulfill them, so that you have a traceability from requirements to your results of your simulation.
I see. As you refer to collaboration, how can simulation accelerate working with remotely working teams, often with people from external partners?
This aspect is really important because simulation expertise for high tech is very diverse and collaboration is crucial. But of course, collaboration is much more than sharing data. For example, it's really helpful if you can review your results on a cloud in a dashboard for decision making. That means you can discuss your results with required stakeholders who might not be simulation expert and who don't need to have the simulation software installed. Then collaboration, of course, also includes project management. And here it is helpful if you, besides the typical project management, have the possibility to directly hand over the data model, the cut data. As we've discussed earlier, it's important to really work on the data model which is needed and not on outdated data. But also you could hand over additional information like the requirements or additional measurements, anything what you would like. And then last but not least, collaboration is something human. And if you can enable a more close collaboration by, for example, sharing your ideas directly in a web-based environment, like a web-based dashboard, then it leads to more direct interaction and in the end to more fun.
I figure a lot of potential for encouraging and accelerating innovation from what you say, Monika. But MODSIM is not just about accelerating collaboration, right? It's also about improving efficiencies and effectiveness.
Yes, indeed. For high-tech companies, first-time right engineering is a must. So back to our connector example, it's really key to embed it into an end-to-end process from the requirements up to the test strategy. Therefore, it is important to, first of all, have requirements defined. So this, in principle, should be the beginning of every engineering process. You can define your requirements on a very high level just by describing what you would like to achieve, but you can specify also up to very detailed levels by really defining parameters which you would like to achieve with your device. And considering that 40 to 50% of development costs actually are used for design verification and validation, it's important to have a sound testing strategy. Therefore, if you can directly connect, for example, your test cases to your corporate requirements, which you have defined earlier, and then in addition, if you have an overview which tells you, for example, if some requirements are untested or maybe some requirements are duplicated tested, this helps to make sure that you exactly test as much as you need, but not more than that. And then in addition, if you do not only perform your tests, but you can also report back, for example, your results, either if it is a simulation or if it's measurement, and you report this in a traceable way back to the context, then this is very helpful to understand where you might have to perform some changes.
Wow, that's a great way to build efficiencies. And how can MODSIM actually help align the test results to the engineering changes?
This is indeed a key aspect. Let's assume the result of our test cycle is that a change is needed. Due to the close connection between modeling and simulation, it is much easier to involve downstream functions early in the design stage and to also directly connect the engineering changes to your CAD model. And then you can also communicate your changes in a transparent and traceable way back to your stakeholders. Of course, if you call your colleague and agree with him on changes, it's a valid approach. But very shortly after, nobody will remember anymore why that change has happened, and all the learning leading to that change is lost. And then if we also think about that change will result into a variant of your model. And then in addition, we also have already many variants in high tech due to, for example, customer specifications or geographical specifications. An additional aspect is that you are able to manage this exploding amount of data, that you can actually specify if you are allowed to work on data or if this is already released or frozen, so that you make sure that everyone has the right access to the data to be working on.
Well, that's very interesting. I think the complexity challenge around the variance is really a serious one, considering the many components that a high-tech company typically has to deal with, regardless of the size of the company. Now, thanks a lot, Monika. Now, let's discuss our last, but certainly not least important aspect of MODSIM, which is about how it helps to optimize R&D resources for maximum performance and efficiencies.
Indeed, reuse of skills, knowledge, and resources is crucial for any high-tech company. One aspect is the ability to leverage tools that users got comfortable with, like the ECAD and MCAD tools. So coming back to our connector examples, where we have experienced that we need to perform a change in our interior design. actually the designer can very easily go back to the environment he's comfortable with, change some parameters, and then via a shared environment, share this directly with the simulation expert. The simulation expert then can directly connect the simulation without having to perform any changes to the setup and use the updated CAD model from the designer. By doing so, this actually brings simulation closer to the design, speeds up the development process, and also helps in gaining mutual understanding and learning. But it also enables concurrent engineering between electronics and mechanical departments by expanding the digital continuity, not only to MCAD tools from Siemens PTC next to our tools from CATIA and SolidWorks, but also to best-in-class ECAD tools from, for example, Cadence, Altium, Zuken, or Mentor Graphics. By having this digital continuity, this reduces actually data translation error and also reduces administrative overhead as, for example, searching for components.
I'm sure that bringing all those different tools and the experts using them together to simulation contributes to much better mutual understanding and learning. Thanks a lot for this, Monika. Now, let me turn to Kamel about this particularly interesting subject of knowledge transfer and also about process automation.
So with pleasure, let's start by the process automation aspect and how it helps improve R&D efficiency. As we said before, simulation of high-tech device is about multiphysics. When simulation experts can build automated simulation workflows, it really helps engineering teams move from a slow linear development process to a fast iterative one. With such workflow, you can simulate, for instance, the thermals and the material stress and the electromagnetic behavior. And you can run this automatic process based on various parameters like processor temperature, different enclosure materials, or design parameters. The other aspect is about knowledge transfer, and we like to call this the new democratization of simulation, which is really to bring the power of simulation into the hands of non-experts or occasional users of simulation tools. Templates are the right vehicle for this. Simulation experts can build those templates for electronics or product designers based on complex simulation process. Those individuals can then use them in a simplified user interface that contains no more than the contextual information they need. After entering just a minimum of variables like title, description, they can trigger certain simulations and see the results right away. This helps product designers and engineers to reduce lengthy feedback loops, and at the same time, it helps simulation experts to minimize unnecessary requests and focus on more complex or critical simulation and process improvements. Last but not least, with a technique we call design of experiments, users can automatically explore various models within a defined design space to rapidly find the best option in relation to the objective defined.
Thanks a lot, Kamel. I'm sure that the democratization aspect is particularly interesting for small and medium-sized companies who don't have the full breadth of simulation expertise in their own organization. But how to synchronize with those experts? This takes us to another aspect driving performance and flexibility. So let's talk about the cloud.
Yeah, indeed. There's several aspects on this for MODSIM. Let me start with the most commonly known enabler, which is the ability to use cloud compute resources. Depending on the size of your job, you can actually send your simulation to compute resources on the cloud. You can flexibly choose there on what kind of size of compute power you need. And also the licensing of this is flexible. So you can balance out peak times, but also idle times. Companies using such compute resources can be either large or small, but in any case, it makes them more efficient and competitive because companies don't need to invest in time, people, and money for having such IT resources in-house.
I imagine this is a very important back-end support for the R&D of fast-growing companies.
Indeed. It is possible to open the front end of the simulation tools on the cloud and do your modeling also on the cloud in a web-based environment, in principle with any device you like. So it can be either your computer, your tablet, or your phone. And therefore, you could, in principle, perform your work from everywhere, every time. But then there's another aspect of the cloud, which is the controlled and secured access to sensitive information. Not only sensitive information, which is the CAD model, but also, for example, requirements. And last but not least, I would like to highlight an aspect which is the cloud data storage. This is implicitly always there, but we would like to mention that it's really helpful to increase the efficiency. For example, where I'm working with my colleague Brian, who's located at the West Coast in US, and I need a model from him. In principle, I would need to wait until he gets back to work. But if I have access to his project, I can directly take it from the cloud, perform my simulations on that, and then when he gets back to work, we can already discuss on the results. So we're much faster and much more efficient than just working in isolated environments. This is especially important if you work around the globe in different time zones.
Sounds great. And we already reached the end of our discussion about MODSIM. Thanks a lot, Monika and Kamel. I'm sure there's a lot of inspiration and insight that everyone with us today will take away. To follow up the discussion, don't hesitate to contact your Dassault Systèmes partner, or we'll make the connection. It's our mission to make your teams and tools as powerful as your vision.
Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.